20 separate fireballs crossed American skies in a single observational window, and NASA's own all-sky cameras captured every single one of them. Not one, not 5, 20. And at least 3 of those events dropped material that survived all the way to the ground. Right now, somewhere between Medina County, Ohio, and the Willowbrook neighborhood of Houston, Texas, there are pieces of the solar system lying on someone's front lawn, and the people walking past them have absolutely no idea what they are looking at. But that is not even the real story. Because what the data actually shows is something that NASA's own Meteoroid Environment Office has been quietly monitoring for months. An anomalous spike in large, energetic fireball events over the continental United States that is not fully explained by the seasonal increase scientists expect this time of year. Yes, there is such a thing as fireball season. Yes, February through April sees a 10 to 30% increase in the appearance rate of bright meteors above the northern hemisphere, clustering especially around the March equinox. Scientists are not entirely certain why. Some believe Earth passes through denser streams of debris during this orbital period, but what is happening right now goes beyond the seasonal baseline. The American Meteor Society logged over 2,369 fireball reports in March 2026 alone. Events with more than 50 simultaneous witness reports, the kind that indicate a truly massive and deeply penetrating object, have doubled compared to the same period in recent years. 3 separate meteorite recoveries were confirmed in a single week. 3 in a single week. The last time the global scientific community saw a recovery rate like that, scientists were standing on the ice of a frozen Russian lake trying to explain to a shocked world what had just happened over a city of 1 million people. Here is what you need to understand about a fireball. A normal shooting star, the kind you wish upon at summer camp, is caused by a particle roughly the size of a grain of sand. A fireball, by NASA's definition, is a meteor brighter than the planet Venus. To produce light that outshines Venus, the object creating that light has to be substantially larger than a grain of sand. It has to be something you could hold in your hand. Or, in the case of the events unfolding right now over America, something that would take both arms to lift and would still break your back trying. The 7-ton object that crossed the skies over northeast Ohio on March 17, 2026 was nearly 6 feet in diameter. 6 feet. That is the height of a tall man. Compressed into a rock moving at 45,000 miles per hour through the atmosphere of Earth. At that speed, the aerodynamic pressure on the leading face of the object generates temperatures exceeding 3,000 degrees Celsius, hot enough to vaporize steel. And that object was not detected until it was already inside the atmosphere. Not 1 second of warning. Not one alert on any phone. It simply appeared in the sky, burning, over a state with a population of nearly 12 million people. And there was nothing anyone could do but watch. The NASA All-Sky Fireball Network. 17 specially built all-sky cameras positioned across New Mexico, Arizona, Alabama, Georgia, Tennessee, Florida, Virginia, and Ohio captured the entry. The cameras have overlapping fields of view, which means the same fireball can be triangulated by multiple stations simultaneously, allowing scientists to calculate precise altitude, precise velocity, precise trajectory, and, critically, whether the object was moving slowly enough and deeply enough to survive as a meteorite. If the fireball is traveling below a certain threshold and penetrates below a certain altitude, survival is possible. And the Ohio event did exactly that. Fragments continued south of the entry corridor, reaching the vicinity of Medina County, a county of 179,000 people, farmers, families, children at school, where pieces of a rock that formed in the early solar system 6 billion years ago came to rest in fields, in yards, possibly on rooftops. On March 21st, just 4 days later, the pattern repeated over Houston, Texas. A 3-foot diameter object traveling at 35,000 miles per hour created a sonic boom that rattled windows across the city. Doppler weather radar, not meteor cameras, weather radar, the kind used to track rain, picked up a debris field spreading from the Willowbrook neighborhood to Northgate Crossing. Houston is a metropolitan area of nearly 3 million people. The debris fell in the afternoon at 4:40 in the afternoon, when children were finishing school, when people were on sidewalks, when traffic was dense on the freeways, and nobody saw it coming. Now you need to feel the weight of what that means. 35,000 miles per hour is approximately 45 times the speed of sound. At that velocity, from the moment the object became visible in the sky to the moment fragments reached the ground, the entire event lasted seconds, not minutes, seconds. Minutes are not hours, and seconds are not minutes. There is no emergency alert that travels at 35,000 miles per hour. There is no text message that outruns a fireball. The monitoring is in place, and detection after entry is possible, but prediction before entry, the kind that would actually save lives, is not for objects of this size. And here is where this story becomes genuinely alarming, because NASA's Planetary Defense Network is calibrated by congressional mandate to track objects 140 meters and larger. objects large enough to penetrate the atmosphere and cause widespread civilizational scale destruction. The 6-foot Ohio rock and the 3-foot Houston rock are nowhere near 140 meters. They are what scientists categorize as meteoroids, objects too small to track in space with current technology, appearing without warning inside the atmosphere at hypersonic speed. And by the time a camera catches them, they are already doing what they do. The system is not dormant. The system is awake and actively processing impacts. The question is not whether more are coming. The question is when, and over which city, and at what angle. To understand why angle matters, you need to understand what happened in the Ural Mountains of Russia on the morning of February 15, 2013. That morning at 09:20 local time, the residents of Chelyabinsk Oblast, a region of more than 1 million people, were beginning their day. Workers were heading to factories. Children were at school desks. An object approximately 20 meters wide, weighing roughly 11,000 metric tons, entered the atmosphere at 19 kilometers per second. That is 6,400 kilometers per hour, traveling on a shallow trajectory from the east-southeast. Because of that shallow angle, rather than plunging directly into the ground and forming a crater, the object skipped through the upper atmosphere like a stone skipping water, building pressure, building heat, building to an explosion that would release energy equivalent to 440 kilotons of TNT. To understand what 440 kilotons feels like, you need to know that the atomic bomb dropped on Hiroshima in 1945 released approximately 15 kilotons. The Chelyabinsk object released 30 times the energy of Hiroshima, not on the ground, in the air, 30 kilometers above the surface. And that distance is what saved lives. Because when the shockwave reached ground level, it had already spread across an enormous volume of atmosphere, distributing its force across 7 cities and over 7,200 buildings simultaneously. 1,500 people were injured. Most of them never saw it coming. They were looking away from windows, or toward them, when the shockwave arrived and the glass exploded inward. The Chelyabinsk superbolide peaked at an apparent magnitude of -27. 3. To give that number a body you can feel, the sun, our sun, 150 million kilometers away, has an apparent magnitude of -26. 7. The Chelyabinsk fireball, for the seconds it burned, was brighter than the sun. People in the region suffered UV burns and temporary retinal damage simply from looking at the sky. This was not a movie. This was not a simulation. This happened on a Tuesday morning while people were eating breakfast. And here is what makes the geological record truly chilling. What Chelyabinsk made clear is that events of this scale are not once-in-a-generation phenomena. They are once-in-a-few-decades phenomena. Before Chelyabinsk, the largest confirmed atmospheric impact since the modern era was the Tunguska event of June 30th, 1908. A remote part of Siberia, early morning. A fireball that witnesses described as a second sun in the sky, hot enough to sear the skin of people standing outside 10 miles from the epicenter. The object, estimated at 50 to 80 meters wide, detonated in the atmosphere and released energy approximately 70 times greater than Chelyabinsk. It flattened 825 square miles of forest. 825 square miles. That is an area larger than the entire city of Los Angeles. Every tree within that zone was knocked flat, pointing outward from a central point like fingers on a splayed hand, the geological signature of something arriving from above at impossible speed. And Tunguska was, by the standards of what the solar system is capable of, a small event over a sparsely populated area in the early 20th century. The question science asks, and has never been able to fully answer, is what happens when an object of Tunguska scale arrives over a city of modern density, not over Siberian forest, over Philadelphia, over Chicago, over Houston, where debris already fell this March while children were leaving school. This is not a theory. This is documented geology. The impact craters scattered across every continent on Earth are not hypothetical. The 2-kilometer Barringer crater in Arizona was created approximately 50,000 years ago by an iron meteorite roughly 50 meters wide, traveling at 12 kilometers per second, releasing energy equivalent to 10 megatons of TNT. That object would have incinerated everything within a radius of several kilometers, and sent a shockwave of lethal overpressure outward for tens of miles. Today, the crater is a tourist destination with a gift shop and a parking lot. The violence that created it is memorialized in souvenir photographs. The scale of what Earth has absorbed is embedded in the rock beneath our feet, and we drive over it on our way to breakfast. Think about Medina County, Ohio. Think about what it looks like at 7 in the morning on a Tuesday in March. The farmland is flat and brown, the last of the winter holding on in the fields. Families of 179,000 people living in a county that probably has one emergency management office with 3 staff members and a backup generator. They woke up that morning, those families, to what sounded like an explosion above the house. Reports to the American Meteor Society described it exactly that way. An explosion above the house. Windows rattled. Car alarms triggered. People stepped outside and looked up and saw the smoke trail threading southward, and they reached for their phones to film it, because that is what humans do now. Because witnessing something is not enough. We must record it as proof that it happened. Proof that the sky did something the sky was not supposed to do. And somewhere south of them, in fields they cannot see from their driveways, pieces of that object were already cold, already sitting in the soil, already waiting for someone to find them. Those pieces are 6 billion years old. They formed before the Earth existed. They traveled hundreds of millions of miles through the vacuum of interplanetary space and arrived without announcement in a field in Ohio on a Tuesday morning. And the people of Medina County will live the rest of their lives without knowing which field. Now connect this to something larger, because the events happening over America right now do not exist in isolation. Nothing Earth does exists in isolation. We are not a rock floating alone. We are a rock embedded in a system, a solar system that is itself in motion, dragging us through the galaxy at 230 kilometers per second as it orbits the Milky Way's center. And the debris field Earth moves through is not uniform. It has structure. It has concentrations. The asteroid belt between Mars and Jupiter is not a wall of solid rock. It is an enormous dispersed cloud of material ranging from dust to objects hundreds of kilometers wide. And Jupiter's immense gravity is constantly pulling material out of stable orbits and sending it inward toward the inner solar system. The Chelyabinsk asteroid almost certainly originated in this belt, its trajectory altered by a gravitational resonance with Jupiter over millions of years, until its orbit intersected ours on a February morning in 2013. Scientists who reconstructed its trajectory found it shared a nearly identical path with a 2-kilometer wide near-Earth asteroid designated 8-039, also known as 1999 NC43, suggesting they were once part of the same parent body. A collision in the asteroid belt millions of years ago that scattered fragments throughout the inner solar system, one of which arrived over Chelyabinsk, and others of which may still be arriving. The question science cannot currently answer is whether the cluster of events over America in early 2026 represents a genuine concentration in Earth's debris environment, or the upper end of normal statistical variation. Both possibilities carry a weight that demands serious attention. One means we are passing through a denser than usual stream of material from a disrupted source somewhere in the belt. The other means this is simply what the solar system is always doing, and what we are experiencing is not an anomaly, but baseline reality, seen clearly for the first time through a network of cameras sophisticated enough to actually record it. And here's the second system that connects to this story, because the atmosphere through which these fireballs are traveling is not a static shield. It breathes. It expands and contracts with the solar cycle, thickening at solar maximum and thinning at solar minimum, changing the altitude at which incoming objects begin to heat, changing the density of resistance they encounter, changing the geometry of where fragmentation occurs, and therefore where debris falls. We are currently near the peak of solar cycle 25, a cycle that NASA's own Solar Dynamics Observatory has described as more active than predicted, with X-class flares and coronal mass ejections impacting Earth's magnetosphere and heating the upper atmosphere in ways that subtly but measurably alter the dynamics of meteoric entry. This is not the cosmic mysticism of a speculative documentary. This is the actual physics of a connected planetary system, where a burst of energy from a star 150 million kilometers away changes the behavior of a rock arriving from the outer solar system. The atmosphere that slows and burns incoming material is not constant. It is a variable layer, modulated by the sun, and right now the sun is near its most energetic point in an 11-year cycle. What that means for the precise altitude of fireball fragmentation over American cities is something scientists are still measuring. What it means for the survivability of fragments to the ground is still being calculated. What the data actually shows is that we are simultaneously in fireball season, near solar maximum, and experiencing an elevated rate of significant meteoroid entries over one of the most densely populated landmasses on the planet. Think about the Willowbrook neighborhood of Houston. It is a community of working families in the northwest quadrant of a city that holds 3 million people within its limits and more than 7 million in its metropolitan area. Single-story houses, driveways, schools within walking distance, playgrounds where children spend the afternoon. On March 21st, 2026, at 4:40 in the afternoon, while those children were in those playgrounds and those families were inside making dinner, debris from a space rock 3 feet wide fell through the sky at 35,000 miles per hour. The sonic boom that accompanied fragmentation rattled windows across the neighborhood. The Doppler radar signature of the falling debris spread across a corridor that encompasses thousands of homes, and every person in those homes had approximately 0 seconds of useful warning. No alert on their phones, no siren, no broadcast. Just the sky making a sound the sky is not supposed to make, and the windows shaking, and the confusion of not knowing whether it was construction or a gas explosion or something else entirely. Because the human brain is not designed to categorize fireball debris at 4:40 in the afternoon in Texas as the first hypothesis. It reaches for the familiar before it reaches for the cosmic. And by the time anyone understood what had happened, it was already over. The debris already on the ground, the event already historical, and the question of whether the next one arrives over a parking lot or a playground still unanswered. NASA's Meteoroid Environment Office runs the All-Sky Fireball Network specifically to build better models of the meteoroid environment around Earth. The data those 17 cameras collect is used by spacecraft designers to understand what material their vehicles will encounter in low Earth orbit and beyond. This is genuinely critical work for the future of human spaceflight, but the network has a secondary function that receives far less attention. It documents the frequency and energy of atmospheric entries over the United States with precision no other system currently matches. And what those 17 cameras are documenting right now is a period of elevated activity that is not yet classified as anomalous by official scientific language, but that is being watched very closely by the researchers who operate the system. Scientists are careful to say that the current spike in fireball reports likely reflects a combination of genuine elevated activity and improved reporting through dashcams, doorbell cameras, and citizen science platforms. And that careful language carries its own warning. Because even discounting the reporting effect, even assuming that half of the apparent increase is explained by better cameras catching events that previously went unrecorded, the residual genuine increase in large, energetic, deeply penetrating events is real. The doubling of events with more than 50 simultaneous witnesses. The 3 meteorite recoveries in 1 week. These cannot be explained by dashcams. These are physical events that reach the ground. The Global Meteor Network, a worldwide system of approximately 300 cameras coordinated with the NASA network, provides the global context for what is happening over America. And the global context is this. Earth is embedded in a debris environment that delivers approximately 100 tons of material to the planet per day, every day, continuously, silently, mostly as dust too small to see and particles that burn harmlessly high in the upper atmosphere. But distributed within that continuous rain of dust is a population of larger objects, the ones that become fireballs, the ones that become bolides, the ones that become events in history books. And that population follows a statistical distribution that science has characterized but cannot predict at the individual level. We know the average. We know the frequency with which events of various energies should occur. We do not know which object, on which day, over which city. The Tunguska object of 1908, an estimated 50 to 88 meters wide, should occur somewhere on Earth roughly every few hundred years, according to the statistical models. The Chelyabinsk object of 2013, 20 meters wide, should occur roughly every 60 to 100 years. The 6-foot Ohio rock and 3-foot Houston rock are at the small end of this spectrum, objects that arrive far more frequently, burn up mostly in the atmosphere, and occasionally deliver fragments to the ground. But the statistical distribution has no memory. It does not know that Chelyabinsk happened in 2013 and therefore will wait patiently for its scheduled century before sending another. Objects arrive on their own orbits, on their own timescales, indifferent to our calendars and our models and our sense of how much time ought to pass between such things. The Lyrid meteor shower peaks on April 21st and 22nd of this year. The Lyrids are a medium-strength annual shower produced by debris from Comet Thatcher, a long-period comet with an orbital period of approximately 415 years. The shower runs from April 14th through April 30th, and in peak years it produces visible fireballs, bright, energetic objects that produce persistent trails and occasionally generate sonic booms. NASA's all-sky cameras will be watching. The American Meteor Society's global network of citizen observers will be watching. 17 cameras positioned across the eastern United States will be recording everything brighter than Venus in the night sky above a country that has already seen 20 confirmed fireballs and 3 ground impacts in the preceding weeks. And mixed within the predictable debris stream of Comet Thatcher, as with every major shower, will be the sporadic background, the random objects that share the shower's geometry by coincidence but originate from entirely different sources, including the asteroid belt, including disrupted comets, including material whose origin has not yet been characterized. What the cameras will show during the Lyrids is what the cameras always show, a sky that is far more active than most people standing beneath it have ever realized, a bombardment that is constant and ancient and ongoing and largely invisible to the unaided eye, punctuated at unpredictable intervals by something large enough to make noise. This is documented geology. The fireball that struck Ohio on March 17th left a chemical trail through the atmosphere that infrasound stations along the eastern seaboard detected as it passed. The sonic boom over Houston on March 21st was captured by weather monitoring infrastructure not designed for meteors, but sensitive enough to record the pressure wave regardless. These events left physical evidence in scientific instruments spread across a continent. They happened. The question is not whether this is real. The question is what it means for the approximately 335 million people living in the continental United States beneath a sky that is, at this moment, delivering space rocks to the ground at a rate higher than any point in recent documented history. And the deeper question, and the one scientists are careful not to phrase too alarmingly but cannot avoid confronting when the data is laid out, is whether the current elevated rate is a temporary cluster or the leading edge of a denser debris stream that Earth will continue to intersect in the weeks and months ahead. That distinction cannot currently be made. The monitoring is in place and the data is being collected and the researchers are at their computers. But prediction at this scale and this size range is not within the current capability of planetary science. Not yet, perhaps not ever, for objects this small. Somewhere tonight, over a city you have visited, or a highway you have driven, or a neighborhood where someone you know lives, another fireball will cross the sky. The NASA cameras may catch it. A dash cam on a highway may film it. A doorbell camera on a quiet suburban street may record the flash and the shadow it casts across the driveway for 1.5 seconds before it is gone. Or it will pass over an empty field, or an ocean, or a mountain range, and leave no witness at all, only the ghost of its chemical trail dissipating in the stratosphere while the world below it sleeps, unaware that the solar system delivered a calling card and left before anyone could answer the door. The 6-foot rock over Ohio, the 3-foot rock over Houston, the 20 events captured by NASA's cameras in this single elevated window, they are not the story. They are the reminder. They are the atmosphere's way of making visible what is otherwise invisible, that Earth has never been alone, that we orbit inside a debris field billions of years old and billions of miles wide, and that the rocks that built this planet are still arriving, quietly, consistently, indifferently, in whatever quantities the solar system decides to send, on whatever schedule it keeps, over whatever city happens to be beneath the sky at that particular moment on that particular day. The monitoring continues. The cameras are on, and the sky is not finished yet.